Today's problem is ASCII range sum. Rating is medium. Can I scoot this over a little bit to see everything? All right. So given a string S consisting of lowercase English letters for every character whose first and last occurrences are at different positions, calculate the sum of ASCII values of characters strictly between its first and last occurrence. Return all such non-zero sums. Order doesn't matter. Okay. So what do we have here? Here's an example. The characters A and B appear more than once. So between the first day and the last day, we have B, A, and C. We can add those up. It's 294. Let's see. Between the first B and the last B, we have A, C, A. We add those up. Constraints. The string will be between 1 and 10 to the 5th in length, 100,000. Time complexity, linear, auxiliary space, O of 1. Topic tags. Prefix sum. And hash. Not sure about the hash. We could do this with a prefix sum, but it's not going to be O of 1 auxiliary space because we would need a second array which is going to be the same size as the string. Now, let me say something about O of 1. O of 1 doesn't mean that we just need one extra variable. It just means that the auxiliary space that we need doesn't vary relative to the input size. Okay, if you're thinking of it just in terms of like, well, I can only use one extra variable, that isn't right. That would kind of send you off in the wrong direction. For example, in this case, we can declare a couple of new arrays, first and last, and they each have 26 elements. Okay? That still counts as O of 1 because even if the string is, whether the string is, length 1 or 10 to the 5th, it doesn't matter. Those don't change. So that's O of 1. First and last. So we can keep track of, for each of the 26 possible characters, we can keep track of where the first one is, and we can keep track of where the last one is. And then, well, let's see, here we go. Let's just go through it like this. We'll initialize them all to -1, and then go through the string, get the index. We're converting by subtracting a lowercase a. We're going to convert characters to indices between 0 and 25, and we're going to keep track of the first index if there is one, and we're going to keep track of the last index if there is one. Now we can compute the ASCII sums between the first and last occurrence. Can I slide that over anymore? See the whole thing? Okay, good. So yeah, so we'll go through these character arrays, and if there is a first occurrence and there is a last occurrence, that is two occurrences that are not the same, then we'll initialize a sum and we'll add, starting with the first character, the first character after the first occurrence up to the character before the last occurrence. For each of those, we'll get the ASCII code, add it to the sum. If the sum turned out to be greater than 0, then we'll add that to the result list, right? Yes, and then return the result list. Let's compile this just as a sanity check. Okay, that seemed to work. All right, we're going to submit then. All right, good. So I guess the key takeaway there is don't misinterpret O of 1. That may send you down the wrong path in solving the problem. O of 1 doesn't mean that you only get like one extra variable. O of 1 just means that your auxiliary space is not dependent on the size of the input. And in this case, it's not. We're going to use two 26-element arrays. Doesn't matter what the input size is. And that's it. Go ahead and like the video, subscribe. You'll get problems of the day in your inbox, and we'll see you next time.